Welcome to the part 2 of R programming. So in this video we are going to learn about different variables. So what is the role of a variable? The variable basically is used to store a value or information. Then once we store it, whenever we want to retrieve that information, we can call that variable by its name and it will display the value or information saved under that variable. Now the examples are like you can see the example here. Input 1 is equal to 200 and input 2 is 6. So the output, what we can do is we can multiply input 1 by input 2 and then we get the result, which is 1200. 200 into 600 is 1200. So this is a very simple example of how we store a value in a variable and then how we use those variables to get a particular desired output. Similarly, for logical and strings, we can store, values such as, so false is a logical value. It could be true also. So A is a variable which stores a logical value, which is false, and the B, again for strings, we can store a value in a variable like this. So you can try these examples in your R. So there are inbuilt functions in R and there are numerable such functions. There are many inbuilt functions which you can call and use in R. So these functions can be used by calling uh, by their predefined names. So there are a few examples here. So for example, sqrt, which means square root. So square root of 9 is 3. Then absolute, so it will give you the absolute value. So it's minus 10. So minus 10, the absolute value of minus 10 is 10. Similarly, there is a variable called function called round. So x, the first argument is the value itself. So here we have entered 25.6537 and we want the round up value up to 3 digits. So this is another argument in this function and therefore you see the result here 25.654. So it has taken the round value of 37 as 4. So in case you want to just get the function by typing just first few letters of the word, you just type the first few letter and press tab on your keyboard. So this R will automatically understand which function you're calling and it will display that function. So vectors is something that is used to store multiple values. So instead of just a variable storing one value, a variable can also store multiple values and that is called vector. So there are three types of vectors: numeric vector, character vector, and logical vector. So if you want to create a empty vector which later you want to use to store a value or a set of values, you can do that as well in R. So you see first is numeric. We are taking the example of numeric. So what you need to do is the function is vector and in the bracket you just write numeric because you want to store numeric values later, although it is an empty vector. And the second argument means the total number of values or elements you want to store in a vector, in this numeric vector. So this is one example of numeric vector, which is again empty vector. The second example is again character or strings, what you call a string. So set of strings or set of characters you want to store in a vector. So you can define this empty vector. The first argument will be character in quotes and the second argument is again how many number of elements you want to store in this. Same goes with the logical vector as well. So examples of vectors with values. So in case you don't want to create an empty vector, you straight away want to create a vector with values. So these are the examples of numeric, then character, and your logical vector. So here you have years, just name of the variable. I've taken the name as of the variable as years, and then you have 2000, 2010, 2020. So these are all numerical values. So you notice here we are using this function called C. So C also stands for concatenate. So basically, if you want to create a vector, you can use C and bracket. Inside the bracket you can enter the value. So if you enter numeric value, it automatically will create numeric vector. If you enter strings or characters, it will automatically create a vector of strings or characters. If you enter logical values, then it will automatically create a logical uh, vector with logical values. So you see the difference between character and logical is you don't use the quotes in logical vector, while in strings you have to use the quotes. So creating a numeric vector, so we have already seen one example, but there are other functions as well. So C, as we see, we've seen already in the previous slide. In this slide, we see also two more functions. One is SEQ and another one is REP. SEQ stands for sequence, REP stands for repeat. So if you see creating a sequence with increments, so suppose you want to create a vector uh, from starting value to the end value, and by incrementing each value by a number. So if you see the example here, so I have defined here a variable a, and using the function ACQ, which is sec. So we want to create a vector which goes from -1 to 2 and incrementing each value by zero point 0.5. So this is the way you create one numeric vector using sequence function. Now you want to create a vector where the vector should have a particular value repeated multiple times. So again, there we can use this function rep, and you first argument is the value or the element that you want to store in that vector, and second argument basically is about how many times it should be repeated. So creating a vector from, let's say, from one value to another and incrementing it by 1. So you can simply create that vector by just using the symbol colon. So here in this example we are creating a vector from 10 to 15, incrementing each value by 1. So then it will create 10, 11, 12, 13, 14 and 15. This is another example. So concatenating multiple numeric vectors. Suppose you want to concatenate all these three variables that we have created here. So we can again use the same function C and put in the bracket the names of those variables uh, and using comma. So we can do that. So see, we have created this and it shows the value here. So if you see the first vector that we created from -1 to 2, incrementing by 0.5. So you see the first one has come here because in this vector, which is a concatenation of A, B, C, the first one is A, and therefore you can see here -1, -0.5, 0, 0.5, 1.0, 1.5, 2. So this is the first vector, the elements of the first vector. The elements of the second vector is this B. So you see 5 has been repeated 5 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And these are the values of the third vector, which is C. So this was the series, right, from 10 to 15. You see 10, then incremented by 1. So 11, 12, 13, 14, 15. Now we can also index a numeric vector in a following way. So suppose we have created a vector here which contains 5 elements, 10, 20, 30, 40 and 100. Now we want the second element of this vector. So we just use the square bracket next to the name of that variable, and inside the square bracket you just enter the index of the element. So we are calling the second element of this vector, so we just put 2 here and we get this. Similarly, if you want more than one element from that vector in a sequence, then you just enter the index of the first element that you want to call and the last element, index of the last element. So here we want from 2 to 4. So this is 2, 3 and 4. So you see this is the result you get. Now if you want different numbers, random numbers, not in a sequence, so then you can just use the C function inside the square bracket, and then you get 1, 3, 5. We want to call first element, then third and the fifth element. So this is how you use this function and you can get the result. Now suppose we want to display all the elements in the vector except one. So you just mention the name that particular index with a minus sign, and it will automatically eliminate that particular element. So you see, when we don't want the first element in the vector, so we just put -1 and it automatically removes that element from this vector. This is just for display, although as the vector doesn't get affected by this, only the display will be this. So you want to, let's say, use this for some mathematical calculation where you don't want the first element. So in that case you can use this particular method, but this doesn't affect the actual vector s. The actual vector s still remains contains the first element. Now the size of the vector, if you want to know, you can use the function length, and then it will tell you the size 5. So there are 5 elements, so it shows 5. Now if you want to alter a value in a vector, so what you can do is you can just mention again in the square bracket, you can mention the particular element and assign it a new value. So here if you see, we change the value from 40 to 50 and it shows 50 here. Now numeric vector operations. So let's look at different operations that we can perform using numeric vectors. So again we define a vector here S and then another vector D. So we can also perform scalar operation. What we mean by that is, let's say you want to multiply each element of this vector S by 5. So you simply multiply by 5 and R will automatically understand that you're trying to multiply each element of the vector by 5 and it will give you the result. So you can see that 10 multiplied by 5 is 50, then 20 into 5 is 100, and 100 into 5 by 5 is 500. Now if you want to do vector to vector operation between two vectors, you can do that as well. So here we have defined two vectors S and D. So if you want to divide the first one by the second one, then we can do that. But the only thing is that the number of elements have to be the same in case you want to do division or multiplication. So that you have to take care of. That's more like mathematics here. So you see we divided S by D, and what we get there is here is like 5 divided by 10 divided by 5 is you get 2. Then 20 divided by 4 you get 5. 30 divided by 3 you get 10. 40 divided by 10 you get 4, and 100 divided by 25 you get 4 again. So if you want to know the sum of all the elements in a numeric vector, you can use the function sum, and in the bracket you put S, the name of the vector, and it will display the result here. Same goes with mean. If you want mean, then use the function mean. One thing you need to remember is that R is case sensitive. So if you are defining a particular variable, so you need to take care of the whether you are using uppercase or lowercase, and all its functions are in lowercase. So again, as I said, that R is case sensitive. So if you're using this function, for example, if you're using mean, then M has to be small. All the letters have to be small. So again, if you want to calculate the mean of this, all the vectors in a vector, all the elements in the vector, then you just use the function mean and it will give you the result. So mean of all these is 40. Now we also have text or string vectors, what we earlier called character vectors. So same way, like if you want to define a single variable with a single string, you can do this. So here I've taken the example of st is a variable name I've given, and help. So again, you remember this quote sign. So for string, you have to use the quote sign, quotation sign. And then if you want to know what is the number of string character in the string in a single variable, a variable containing a single string, then you use nchar, nchar, and this will give you the total number of characters in a string. Now, same way as we have done it for numeric vector, we can also use a variable to create a vector of strings. So here is example. M is the name of the variable, and you use the C function. So, and then inside the bracket you enter all the data or the variables, or sorry, the values, the elements or the strings. So here I've just calculated a small example of months, Jan, Feb, March, April, May, but each value is in a quotation sign. Now next, if you want to know the number of elements in a vector, again same, you use the function length. Now if you want to alter the value of a particular element in index in the vector, you do the same like as we did for numeric vector. Name of the variable, square bracket, inside the square bracket you put the index of that particular element that you want to replace with a new value, and then the new value, assign it a new value. Now how to index it goes the same way as any other vector. So again, second element, the 2, the second in the square bracket you put 2 and you get this. From like a sequence, if you want from second to 4, then you just use a colon 2 colon 4 and you get Feb, March and April. Now if you want the random numbers like 1, 3, 5, so you use the C function inside the square bracket, and remember we replace this month May with December, so that's why we are getting December here. Now logical vectors. So again, you can define a single value variable, and here you don't need to use quotation sign because it's a logical vector or logical value. So same way we can create a vector of logical values. So just named it L, and then again the C function has in the C function you can put in all the values like true, false, false, true, true. Again, if you want to know the length or the number of elements in that vector, same, you use the function length. Now you want to index, again same like logical numerical vector. So L in the square bracket 2 will give you the second element of the vector. Then 2 to 4, 2, 3, 4. Then random number 1, 3, 5. Then again you get the same result here. Now if you want to alter the value, again you can do the same way here. Just mention the name of this the index number, and it will change the value of that particular index element. So we are replacing here, the second one is false, but we are replacing it with true. Now you see the result. So L, now if you display the values, you'll get the second element has been changed from false to true. Now logical and numeric vectors, what we can do is there are certain things which we can do with numeric and logical vectors together. So again, we have defined that earlier. We defined S as a numeric vector and L as a logical vector. So when you multiply S, which is numeric vector, and L as logical vector, what you get is this result. What it basically doing is that it's converting the logical values into ones and zeros. So all the trues become ones, and all the false become zeros. So that's what is happening. If you see, we have multiplied, so it is element wise multiplication. So this 10 is multiplied by true, so it gives you 10 because true is 1. 20 multiplied by true, that is 1 again. And 30, you see 30, and here it is false. Third element is false. False is 0, so 30 has become 0, and 40 and 10. Now if you want to concatenate S and L, which is S is your numeric vector and L is your logic vector, in that case what happens is it automatically converts all the logical values in logical vector into ones and zeros, and this is what has happened here. If you want to just convert a logical vector into a numeric vector, all you need to do is multiply that logical vector by 1, and that's what you get here. So try all the examples in this presentation and for yourself so that you get hang of it. Moreover, we have not covered all the functions. It's just to get you initiated into R and its functions, and initializing the vectors and variables. So it's a very simple presentation, just giving you overview of what all you can do here. Later on, maybe we'll work on some video where we'll look at each function and just create a separate video for all the functions. So thank you very much for your patience and going through this presentation. In case you like this video, please like, share, and subscribe. Thank you so much.